Good morning, good afternoon, everyone. Today we're going to continue our discussion of multiple linear regression model. By way of review, we said that multiple linear regression allows us to establish a relationship between your variable of interest, dependent variable, using your independent variables or your predictor variables in order to explain your dependent variable. Now, the model that's generated using the method of least squares, okay, we explained this last time, method of least squares, okay, generates the values for your intercept, the slope for your explanatory variable 1, 2, etc., depending on how many parameters or how many independent variables you're using. Okay. And this value is actually class your predicted value. If you take a particular uh, row of observation, you'll have your observed value, okay, and then use the model in order to predict your value of y, your dependent variable. So this part of the equation here is your predicted value, y hat. We said that this is your y hat, predicted value, model value, okay, and it's equal to there may be times when it's actually exactly equal to your dependent variable or observed value. But oftentimes, there will be a deviation. Okay, your predicted value. So if we plot it, okay, this is our model value. Your predicted values are all coming from this line. And let's say this is your actual value. So the difference between your actual value and your predicted value, okay, sorry, the difference, okay, this height here is your residual. Okay, so some residuals will be, okay, because if we simplify this, we'll have your epsilon, okay, your predicted value is equal, your residual is equal to your actual value minus your predicted value, right? It's basic math, okay? So this is your actual value, subtract the predicted value, you get your residual. And this is your residual, this is your predicted value, okay? This is your y hat. Y hat at this instance, this is your y sub I, okay, at this particular value class. And the difference here is your epsilon, the residual, okay? So you have several points here. Each one will have their own residuals. There may be some that are exactly on the line, so there will be no residuals. Now, if you get all of these residuals, drop a vertical line to your regression line, and then if we sum this all up, if we sum all our residuals, we learned that it will equal to 0. So we're saying that one of the conditions of multiple linear regression is that the expected value of your residuals given your x's, okay? So these are your parameters given your x, okay, the values of your x, and inputting it, the residuals, okay, is equal to 0. So this is the same as the average, okay? The average residuals average is equal to 0. Why is the average equal to 0 class? How do you get the average? You sum up all your residuals divided by the number of observations. So if the sum of your residuals is equal to 0, okay, and you divide it by, let's say, the number of observations n, then you get 0, right? So it's just the same as saying the average of your residuals is equal to 0. And it comes from the fact that the sum of the residuals is equal to 0. Okay. Again, if you sum up all the residuals and if it's equal to 0, then getting the average, which is just dividing by n, will also give you 0. Okay. So in multiple linear regression, to compute for the what's this least squares, okay, in order to compute that, we don't use this summation of your residuals is equal to 0. Rather, what we use is your residuals, okay, residual squared, okay? And then we sum that up. We sum up all the residuals, and then you get the minimum, okay? Minimum of the sum of the squares of the residuals. That's why it's called least squares. And how does that happen? If this line, this regression line, is a unique line. When I say unique, you can only have one regression line. If I put a bit of an angle here, okay, if I, let's say, just a little bit like this one. So this line, of course, it will have different betas because the betas are the slopes. So if we have this line class as your regression line, the residuals will be different. And the residuals will not be the minimum. Okay. So the line, which is called the line of best fit, that gives us the minimum of the sum of your residual squared, is your regression line. And it's a one and only one line. One and only one line will give you will give you it will give you the minimum squared residuals, minimum sum of your squared residuals. Okay. So that's the process class. And in order to get this class, we have to make use of calculus. Okay. However, we're not going to do that in this subject. We will assume that the process of getting the parameters, okay, because that's the goal of this model, to be able to define your parameters, beta null, beta 1, beta 2, because without them, then you don't have any model. So the objective is to be able to solve that, but there's a process to do that. The process is we have to come up with, it's actually iterative, okay? If you try one line with the different slopes, compare that with the another line, okay? However, the best way really is to use calculus in order to solve for your parameters. Okay, so let me clear that and continue, class. So we looked at these assumptions of linearity. I'm not going to look at that again. So let's go here, okay? And let's now move on to loading the packages again. We did this last time. So the packages that we're going to use are Psych, HMISC, Broom, Tidyverse, Desk Tools, SchemR, etc. So these are packages used for descriptive statistics. So let's load that now. Okay. Kindly load your packages. Every time you close and open R, you will need to load these packages, except for the packages that are preloaded with R. It's like stats, the stats package. You don't have to load the stats package. But this ones, Desk Tools, SchemR, GG45, Stargazer, those are packages that come preloaded with R. So sorry, they do not come preloaded with R. So you need to load them. Okay, so I have loaded it. You may check also. Okay, so let's now. I don't know if we have imported the wage data set, but let's do that. Make sure that the wage data set that I shared with you is saved in your in your R project. Otherwise, if this was outside your R project, then accessing that file, that wage.csv, will be a bit more, let's say, a bit more complicated. Why complicated? Because you will have to define the file location of this data set. But since we have loaded it into our R markdown file, into our R project, sorry, R project, then the the code is very simple. So this is coming from your read R. So as I said, sometimes it might be good for you to identify the package from where it comes from, so that at least you're aware that this read.csv is coming from readr. And notice we did not load readr. However, readr comes packaged with tidyverse. So if you load tidyverse, automatically readr will also be loaded. So the function is read_csv, okay, and then you just identify the file. Since the file is already loaded in our R project, no problem. Otherwise, you would have just like this, okay, where you saved your file, you would have defined the file location. Okay. So this is advantageous for us. It makes the code simple. And then we need to define whether there are column names for our data. So if we run this class, what happens is that a wage object is created because that's the name we gave to our file, okay, to our object class. And it tells us there are 526 rows of observation and 8 variables. Now, take note here. We have here some explanation about the data. This is called your metadata. Now, it does not happen for all data sets. Okay, so there are data sets that, especially tables that already have this metadata. Okay, so let's look at this. It's the same, 526 rows and columns 8. The delimiter is a comma, that's why it's a CSV file. Okay, comma separated values. And then in the data, you have 3 variables that are character, race, gender, civil status. That's your data type, character. And there are 5 variables that have double or numerical. Double meaning that they can take on decimal places. Unlike if it's integer, it will not take on decimal places. Okay, education, experience, tenure, number of dependents, and hourly wage. Okay, so this is our metadata. Now it says here that specify the column types or set show column types is equal to false to quiet this message. So let's try that. Okay, comma, and then if you type this, says that you if you include this, okay, show column types is equal to false, then I'll close this first. When you run this, okay, so same thing. Let me redo that. I'll remove wage just to show that we're able to load, remove wage here, RM. So no wage. So I remove the object. Now I'm going to rerun this. I'm creating wage using the read_csv coming from the readr package. I'm loading the wage.csv. It's here. Okay. Column names is equal to true. And if I don't want to show the types of column types, I'll have to include this. Control Enter. Okay. Now for me, I don't I don't mind including this. Okay. It's added information, quick information. So I just I don't include that as part of my code. Okay. Any information that I could learn about the data is much accepted there. All right. So at least specify the column types are set. Okay. to be false, to quiet the message. You can even use spec, but I'll leave you class to explore that. All right, now once you have the data loaded to your environment, you can either click this or type view, the name of the object, view wage, and it will, let me close this first. Okay, so I'll click this and it's equivalent to view wage, and then it will have a printout in one of the tabs here, wage. And you can see here, this is a data frame. A data frame is different from a vector. Okay, so I hope you have already watched the videos on data types and data structures, because that's very important. Please don't watch it close to the exams. There are some details there that you need to know as early as possible. Okay, so you have 8 variables here. 5 are numerical, education, experience, tenure, number of dependents, okay, number of dependents, and hourly wage. And the 3 here are categorical or character. There are 526 observations, okay, 8 columns. So that's what this view, then the object will give us. Okay, and this is for data frame. If it's a vector, it will not show this. All right, and then let's get the class. The class of wage class. So what does class tell us? That it's a data frame. There. Special table data frame, table data frame, table, and data dot frame. So these are the different nomenclatures of our data. Okay, data frame. All right. Then we can get also the structure. The structure tells us more about our data. If we run structure, then we'll see that this one, it's a special table, 526 by 8. Okay, the other names are special table, a data frame, etc. And you have here education, experience, numeric, character, 526 observations, and here's a list of the first few observations. Okay. Now here we're told that these are the attributes of spec. Okay. Columns, education is double, experience is double. As I mentioned, double is used as a type for numeric variables, which can take on a decimal places. Okay. For for integer, it's just int, int. And double here stands for the memory allotted for that, because of course, if you have a decimal place, it will need more more spaces or more memory as compared to an integer, no decimal places, column, character, etc. All right. So now I just want to comment about this, the dollar here. Now, kindly get the notice that education is numeric, right? It's numeric. What will happen if I get the average of education? Could you please try that and tell me what happens? Let's see if we can get the average. And we know that we can get the average of a numerical variable. It's just adding all the observations and then dividing it by the number of observations. That will be your average. So could you kindly comment, please, on what do you get if you use the function mean average of education? Feedback, please, class. What did you get? Okay, if you run this class, you'll get object education not found. And the reason for that is in your environment, Excel only recognizes wage. Excel does not recognize education. Excel does not recognize experience, tenure, etc. None of these are recognized by Excel, I mean, because it's inside it's inside the wage data set. So how do you access this? That's now the purpose of the dollar sign. Okay, the dollar sign here tells us that if you want to access education, then you have to do wage dollar. Now notice if I type, okay, let me go back, mean wage dollar. Notice that when I type dollar, it gives us this intelligence. What are the variables inside wage? And the first one is education tab, okay? Control enter. There you go. It's correct, 12.56. But only if you access education via wage. Okay, the same thing. If I want the standard deviation, wage dollar, then say tenure. So that's a standard deviation. Okay. If I get the variance, for example, var of wage dollar, then let me choose a categorical variable race. Okay. Now, it says here that NA, why? Because race is a categorical variable, and race does not have you cannot compute for the variance of a categorical variable. All right. So that's what I wanted to point out. Now, okay. So, um, what about the structure? Class? Structure. What does this give us? Yeah, we already did structure, right? So this was the structure, the one that showed us the dollar sign. And then how about summary? Summary gives us the 6-number summary for the numerical variables. Let me repeat. Okay, here. Okay, so you have here education, experience, tenure, numerical variables, and we can compute first quartile, second, third quartile, minimum, maximum, and even the average. Also for the two other number of dependents and hourly wage. So this is what summary gives us. However, the character variables, since we cannot compute its first quartile, second quartile, etc., only the count will be given. Okay, only the count will be given. All right, so that's what the summary function gives us. Now, there are other packages that provide very good outputs as far as descriptive statistics is concerned. dplyr, which comes from tidyverse also. This is a good package for data manipulation. It has its glimpse function. So let's try glimpse. Of course, I can remove this. However, for familiarity, I want us to know that the glimpse function comes from dplyr. Okay, control enter. Then it's like summary. Sorry, it's like structure. Okay, it's like structure where you're given the rows and columns, and then the nature of each of the variables here. Dollar education is double, gives us the first few observations, etc. So that's your glimpse function. Now, for to create a cross tabulation, okay, we can use the table function. The table function will give us the distribution of your categorical variables by level. Okay, for example, race is white, non-white. So how many are white, how many are non-white, etc. So depending on the number of levels, then the levels refer to the different types. Okay, for example, if it's college, so you have frosh, sophomore, junior, senior, and graduating, for example. So there are 5 levels there. For this all of them have only 2 levels each. So if I run this using the table function, table, then once again, I have to use wage because R will not understand race, gender, and civil status. Control Enter. Then it gives us, okay, the count class. Okay. So 54 non-white, white is 472. Okay, I think, let me see. Table, while you're writing, let me see the syntax for table. Okay, table. I'd like to get the proportion. Okay. Sorry, it's hang. I have the exact PQRS. Not here. Anyway, gosh. uh, let me just, I forgot the proportion here. Okay, so let me check. Let me just copy one here because instead of the numbers, we can ask R to give the proportion. Okay, I'll just try. I forgot the exact code. Let's see. Okay, let me copy this. Control C, Control V, and then I think it's proportion. P, ROP. Is that proportion that table here? Parenthesis. Okay, let me see this class. It's wrong. So is it equal to true? I don't think so. Okay, anyway, I try to find out again because we can use proportion table here and it will give us not the absolute values, but the proportion. I forgot the exact code for that, but it's prop that, okay, anyway, you can just find out outside this class. Okay, so let me continue. Boy, my computer is terrible. All right. So we can also use other packages like here. Let's perform other descriptive statistics. I will not give you the, I'll just give you the title here. I won't give you the code. I want you to write the code. There's this package called Psych. We loaded this a while ago. And Psych and HMISC have two common have two common functions described. So sometimes you might need to attach the namespace. Okay? the namesake, psych, or HMISC in order for R to know which is which. Okay. Or sometimes R will tell us which is masked. So which of the two will prevail. Okay, so that you don't have to write the namespace. All right, so psych. And what does this give us? It gives us, again, descriptive statistics and the number of observations, mean. But here you have an asterisk here. You notice that for the categorical variables, they have metrics also. Okay, of course, that does not have any meaning. What R did is just to replace, for example, race, white and non-white. It will replace one one level by one and the other by zero. So since they have been replaced by binary numbers, okay, or if there are three levels and maybe 1, 2, 3, 4, 5, or 1, 2, 3, that's how you get the average for race, gender, and civil status. Of course, that does not have any meaning. So we tend not to just ignore that. So we have standard deviation, median, trimmed median, mean absolute deviation, minimum, maximum. Okay. So you have your range, skewness, and kurtosis, and standard error. Now, of course, it is incumbent upon you to review these metrics. Okay, we're not going to go there, but they can be part of the exams. Okay, I can ask you about the meaning of skewness. Okay, so because it's very relevant to our discussion. However, the assumption here is that you should know these things already. So a little review from you about descriptive statistics, about measures of central tendency, etc. will do well for you. Okay, so let's take a look at the described by this time HMISC. So you notice I attach here the package HMISC and then describe. Let's see what happens. Okay, you can now see that, okay, this seems to be more comprehensive, pero mukhang ang daming ano, no? It has a lot of information here. 8 variables, 526 observations. So it takes a look at this one by one. Okay, so N, 526. Okay, then we have, what's this? 0.25. Okay. There are missing GMD, 0.25, 0.5. So I think this is the percentile. Okay. So the 5th percentile, I think, is 8. The 10th, the first decile or the 10th percentile is 9. Then the 25th percentile, which is this is the first quartile. This is the 50th percentile, or this is the second quartile, third quartile, 90th percentile, etc. So you have your percentiles there. Then you have the values. So education, although it's a double, the values there are shown in as integers. Okay, so here you have a distribution. Those with 5 years experience in this data set, there's one. There's one. 10 years, there are 30. And then you have, if you take the maximum, the mode, it will be 12 years, where there are 128, 98 observations. Okay, so it just gives you a distribution of the the frequency distribution of your data. Okay, and then the proportion here. It's just a percentage of the whole. So those with 12 years of educational experience comprise around 38% of the sample size. Okay, and you did the same for each of the variables. Education, experience, exactly the same thing. Okay. But here there are some here lowest, highest. There's a bit of a difference between how education and experience were presented. And then you have here the categorical variables, okay? And then same thing with the other numerical variables. So that's how your HMIS describe function, the result it generates. So more informative than the psych describe function. Then we have describe by, okay? So describe by, also from the psych package, you identify the data set, and then what do you want, how do you want your data to be described? You want it to be split by gender. So same thing we describe. However, now you have a categorization. You'll have now descriptive statistics for male and descriptive statistics for female. Okay, so let's take a look at this. All right, so you notice there are now three outputs here. The first one shows you the grouping, descriptive statistics by group, female and male. Okay, so if you take a look at this, all right, so these are the female data, 252 female respondents, and these are their means, standard deviations, etc. And then if you go to the next one, sorry. This, on the other hand, are the males, 274. Okay, you also have the same metrics as the described: standard deviation, median, trimmed median, mean absolute deviation, etc. All right, so let me pause for a while and seek your feedback, please. So far, are you able to follow? Were you able to generate the results from this descriptive statistics functions? Any questions? Thank you. Thank you. Let's wait for the others to give their comments. Somewhat. Okay. Christian, anything you want me to repeat or to clarify? Okay, Christian, anything there you want clarified? And how about the rest class? Okay, no clarification. All right, sige. Let's move on, class. So we were comparing describe from psych and describe from HMIS. HMIS seems to be more comprehensive, but you can use describe by and and provide descriptive statistics for the levels that your categorical variable has. You can do this, for example. How about this? Describe by hourly wage and then race. Okay. What will happen about this? Your hourly wage is a numerical variable, and then your race is categorical. Enter. So what do you have here? So you're only going to provide, okay, descriptive statistics for hourly wage. But this time, okay, it will be classified between non-white and white. Okay, so I'm just looking at hourly wage here. Okay, white and non-white. So you can specify a particular variable to describe and and classify it into levels. All right. So any questions about that, class? No questions? All right. So let's now try to plot plotting the data. If we plot hourly wage, what will you get, class? I'll wait for your responses. If you plot hourly wage, what do you get? I hope we can give quicker feedback, class, so that we can move on faster. What do you get if you plot hourly wage? Anyone? Error, correct. You'll have an error, class. Once again, because this is not recognized by R. If you check your environment, there's no such thing here as hourly wage. If you have hourly wage object here, then it will plot it. But here, none. Okay, that would be an error. However, if I identify from which object it's coming from, okay, then it will recognize that. So this is your plot for hourly wage. All right. Then we can also do this. Okay, this is another way to do it. We plot education and then we identify. Okay, sorry. This one, it will not plot also because R does not recognize education and hourly wage. However, if we plot wage education and wage hourly wage, then it will create a plot. So I'll give you a few seconds to try the third one, the row 166, plotting the variables of a particular object, and then plotting the variables with the object. Once you're done, class, kindly please chat. Would like to be on the same page as the first section. So if you're done, class, kindly please chat. Thank you. All right, good. Okay, good. So this one will not yield anything. It will not recognize education and hourly wage. This one will recognize education and hourly wage. So this is a bivariate plot. It's a scatter plot, class. Scatter plot. On the x-axis would be education. On the y-axis would be hourly wage. So the first one will always be the x-axis and then the y-axis. So if I plot this, I'll go here, Control Enter, then we get a scatter plot of your hourly wage and education and hourly wage. Notice the first variable here is your x-axis. So education is here. The second variable is your y-axis. Take note of if I change this, then education will be on the y-axis. Okay. So I hope you're all are able to follow. I hope I'm not going that fast. All right. Then how are we able, class, to get? Is it possible to get the mean of hourly wage even if it's not here? Yes. What we do is to use this function attach. So when you use attach wage, R will understand that all the codes or commands that follow all belong. If there's a variable that's with wage, then it will run it because you have attached wage to it. Okay, so if I attach wage, okay, and then if I get the mean of wage, okay, it gives us the answer. Even if I did not write mean wage dollar hourly wage. Okay, because attaching it tells R that all the variables that come after this, okay, unless you identify another data set is coming from wage. Okay, in fact, if we plot, okay, let's plot education. Okay, so this is the plot of education. There, it was able to recognize it. Now, oftentimes you might be working with several data sets. So if you're done with using wage, it would be good practice to detach it if you're not going to use it again, or if you're going to use it, but it's more convenient to just append wage and then dollar. So if I detach wage, notice that if I get the mean of number of depth, mean of that, control enter. Oops, sorry. Did I detach wage? I don't think I run this. Detach wage. Okay, so wage is detached. Then if I get mean of num depth, okay, that should be error. Not found because wage was detached already. Okay, once again, pause and ask your feedback if you're able to follow. I'm evaluating my pace because if I'm too fast, then I would appreciate you telling me that I'm going too fast. As I said, this is not a matter of me being able to discuss the lesson without you understanding. That's the last thing that I hope that I will wish for or I'll do in this class. I want that our pace is okay. You're able to follow, you're able to understand the lesson. Okay, good. Although only 7 replied, I hope the others will also reply because we are 33 class in this classroom. So 7 of you, that means 7, only 20% class is responding. So that's a pretty low participation rate. I would at least 80, so that means 30 times 80, around 25, 26 of you will respond. Next time, class, please. Okay? So because I don't know why you're not responding. One reason could be you're already outside of your attendant, you're still there, but you're outside doing something. Or maybe I'm talking too fast. Okay? But you'll have to tell me because I cannot guess, class. All right. So this one, it's okay because even if wage is not attached, we identify where these objects are coming from. And title of the plot, scatter plot of hourly wage and education. And don't forget, by the way, I already forgot to give it names. It would be good practice to always give it names. Okay. Now, we said that in multiple linear regression, we want the dependent variable and the independent variable to be highly correlated. Okay? Because if they're highly correlated, then that means their direction are going together either upward or downward. So we can relate the movement of one of the, in this case, hourly wage with the other variable. So if we get the function core of wage, let's run this. What do we have here? So we cannot run correlation of wage because wage contains uh, categorical variable or character variables. So it will not run. Okay, but we can use this one from the psych package. We have already loaded this. We can make use of the pairs panels function. So let's run this. Pairs.panels come from your psych package. Control enter. Okay, and we have mm, quite a diagram here. So just printing it. So why doesn't it print? Anyway, I just use this. Okay, so we have here, okay, so this is what we call a correlation matrix, but not only the correlations, on the lower part of your matrix, of your rectangular matrix, you have the plots, okay? The plot here, class, the diagonal, is the plot of the variable itself. So here we have your histogram. Okay, experience, tenure, race. You notice that it's just since there are two values, you have the smaller one and the big one. For gender, they're about balanced, 252 and 274, I think. Civil status also. Number of dependents. Okay, number of dependents class. It's, well, of course, just like education, you have there the frequency distribution and the plot hourly wage. All right, then the numbers here, class, are your correlations. So how do we read this correlation? So you go to the left and go down, okay, or go to the right. In this case, left, down. So left education, down experience. So this is the correlation between education and experience, which tells us that education and experience are negatively correlated. When one when one factor goes up, then the other factor goes down. So that's what we mean by negative correlation. Okay, for others, for example, this one class. Let's focus on hourly wage, which is our dependent variable, and try to see which of the variables is most correlated with it. So here, point 41, you go to the left, education, you go down, hourly wage. So this is the correlation between education and hourly wage. So among the correlations here, this is the highest. So if we're going to choose one predictor for hourly wage, it should be uh, education based on their correlation. Okay. The next is tenure. And here you have, okay, although gender class, 0.34. So we said that this is not actually a correlation, okay? Because this is and also race, it's a categorical variable. And what R did here was just to replace race with white and non-white. Non-white is 1, white is 0. So each of the elements there have values already 1 or 0, and then it can now get the correlation. Okay, but that's not meaningful. Okay, so if we're going to choose one variable to predict hourly wage, it will be education. The list will be among the numerical variables. The list will be okay, the list will be the number of dependents is 0.05. This one is 0.04. Oh, that's race. Okay, so it will be number of dependents. Surprisingly, the number of dependents, well, not necessarily, does not have anything to do with the hourly wage of the individual in the office. Okay. We can also make use of another correlation matrix. Okay, kindly first, maybe we have not installed GG Ally. Okay, kindly install GG Ally, please. You can make use of the packages here. And then install GG Ally. I'll give you a few seconds. And then let's see what GG Ally can do. And make sure you load it, class. Or you can use Pacman Pload for GG Ally. That's also convenient. Okay, feedback, please. Were you able to get it? Okay, I'll assume that you were able to load GG Ally, and then using the GG pairs function, take a look at this, GG pairs, wage, control, enter. Then it's a bit more, let's say, better looking plot compared to your pairs.panos. But it's almost the same. So it's loading. There. Okay, so if we go down here, Okay, so what do we have here? Same thing as the one with pairs that panels, but this time you can see that number one, it shows significance of correlation. 3 stars mean it's significant at 0.05 or 0.001, sorry. That's 3 stars. Okay, and then just like the other one, here you have the this is the box and whisker plot for the two levels. All right, so you can gather some bits of information here. Okay. All right. Now, uh, since it looks like the categorical variables and the correlations there do not have really any meaning, so we can take that out so that our table becomes neat, and then the values that you get there are all relevant or uh, have a meaning. Okay, so what do we do? If you recall, our wage data set has race, gender, civil status. These are your categorical variables, and they're in columns 4, 5, 6. So what we can do is to create an object where these variables do not appear, okay, or are not there, are not present there. So if you take a look at this, okay, let me. I'm creating this wage one data set, and then brackets, square brackets. That symbol is for subsetting, which means that I can get any part of this, create a val, a, ba, an ob, a data out of it. I can subset this one. I can subset only race, gender, civil status. That's okay, if that's what you need. So how do we do that? We use these brackets, okay? And then take note, this is this is a data frame. So you have rows and columns. So for the first part, you'll have to identify the rows. If you take a look at this, uh, what I want to do here is to, as an example first, let's create education. Let's just create education as a as a data frame. Education. So one column only. So how do I do that? Number of rows. So for education, there are 526. So I'll put here 526, comma, 1. Okay, so this is 526 rows, row 526, and first column. If I run this class, wage one, you'll notice that it will only be one element there. Why? Because in your code, you're saying, I want only row 526 and row 1. Okay, that's not what we need. We need rows 1 up to 526, everything there. Okay, I hope you got me. Everything here. Okay, and then just, sorry, everything, all the rows and only the first column. So how do you do that? To make it all the rows, you can index it from 1 up to 526. Okay, that's one way to go. Or just leave it blank. Leaving it blank will means that include everything. And just include the first one. Okay, I'll use the same object to overwrite it. Control Enter. And now you can see that there are 526 observations, one variable. If I click this one, then that's what that's what we wanted to do. Okay. Now let's create again wage one, but this time we want to create only, okay, only from wage data set 1, 2, 3, 6, 7. In other words, we want to delete rows, columns 4, 5, 6. So how do we delete columns 4, 5, 6? It's very easy. Again, we concatenate C, and then remember it's 4 to 6, right? But we put a negative here. to indicate that you are not including you're not including columns 4 to 6. And then I include all the rows. For columns, it's everything except 4 to 6. So if I run this, control enter, now you can see that our wage has 5 variables, 4, 5, 6. Okay. Yeah, 4, 5, 6. And let's print this. Let's see. Here. 1, 2, 3, 4, 5. All the they're only all quantitative or numerical columns. Okay. So if we now use the pairs.panels ggp in site package, and then just run this for wage 1, which is only numerical. Okay. Okay, so we have a better appreciation of of the correlation matrix. So, however, in the pairs.panels, it does not show the significance of the correlation. But anyway, what's negative 0.3? Once again, you go to the left and down. So this is the intersection of education and experience. It tells us the correlation between education and experience. For hourly wage, we said that this is what we want. The dependent variable should be highly correlated with your independent variable. And also this one, class, take a look at this. 0.5, go to the left, experience, go down, tenure, 0.5. So this means that the correlation between experience and tenure is quite related. Okay, now, again, caveat, class, warning. We don't want that situation where your independent variables are very much correlated, because we will be falling into multicollinearity. With multicollinearity, your independent variables are highly correlated. So if you take a look at this ones, excluding hourly wage, tenure and experience seems to be the most problematic. Next is education and experience. And then a little bit of education and number of dependents. The rest are less than 10%. So not too much, not a problem with them. Okay. So this is your pairs.panels. You can also use this GG ally, GG pairs, which I find more better. Okay. Okay, so despite again with its color. Okay. And then here, okay, you can see the significance. Okay. And the titlings are better placed. Okay, so just like I said a while ago, the correlation between education and hourly wage is the highest, 0.41 approximately, and it's statistically significant. So if you're just going to use one predictor for hourly wage, hands down choice, education. Okay, so let's continue. Okay, good, because we're able to follow the other section. We stopped here, and I would want us to stop here. Okay, we're now moving towards creating our first linear model. A while ago, we said that if we're going to model hourly wage, it's if you're going to use simple linear regression, by simple I mean one predictor, then the the best candidate most probably will be the one that has a high correlation. Okay, so here, hourly wage, education, and then we identify the data is equal to wage. So this is how you write a syntax for linear model. LM stands for linear model. Okay, so we're creating this object, mod1, mod1, however you want to name it. It's arbitrary. I gave it a name, simple reg, and we use LM, which means linear model. The first item here, the first figure here, variable here is your dependent variable, and then tilde, which means associated with education. So we're trying to associate hourly wage with education. Only one. If you're using multiple linear regression, then we could have placed here another one, expert. Okay, expert. Or if you wanted all the other variables, just use this tilde and then dot. That means that R will use all the the data in your wage data, except of course the hourly wage. Okay, for now, let's just use education. Okay, so if you run this class, control enter, okay, you notice what happens in your environment under data, not under values. You have this mod 1. And it's quite different from this one. Wage is data frame. This one is a list. Okay, if I click this class, it will give us the list of objects that are inside this mod 1. So if you recall, class, or I hope you have watched the data structures, the different types of data structures could be vectors, could be lists, okay, could be matrices, could be data frames. Okay, and list is different from vector because a vector can only contain one type of data. So a vector may be all numbers, all integers, all letters, all logical values, etc. That's a vector. For list can contain different types of objects, can be uh, vector, can be character, can be whatever class, and it can be another list. So a list can contain another list. All right, and what's here, class? We can find here the coefficients, 0.905, 0.541. You can find here all the residuals. Okay? So as we said, this is the difference between your observed value and your predicted value and others, class. In fact, if you run here names, names of mod 1, let's take a look what's inside mod 1, control enter. There are the names of mod 1. And since these ones are inside the object mod 1, we can access that mod 1 dollar. Take note when you type dollar, then it gives us the what's inside, which are these ones, 12 all in all. So let me check, for example, let me check here, coefficients. Tab, control enter. Then we have the values of coefficients. Okay, so this is your intercept and this is your slope for education. So for example, if I want mod 1 dollar, then residuals. So it will give us all the residuals class, all the difference between your, for example, for this one, number 1, negative 1.95. If it go to wage class, okay, our hourly wage is hourly wage is 3.10, okay? Okay, and let's get, okay, let me first get this mod 1 dollar fitted values. Mod 1 dollar. Here class, fitted values are your predicted values. Okay, control enter. So for your for your first observation, where's that? Let's copy this. The predicted value is this one. Fitted value means predicted, right? 5.05. And what's the actual value? The observed value is 3.1. This is the first observation. Copy this, Control C, Control V. So let me get the difference between, what's the difference between your observed value and your predicted value? Okay, Control Enter. It's negative 1.9501. Once again, we take a look at our our residuals. Here, residuals. Negative 1.9501. Control C. Control V. Okay, this one has been truncated, but you see that they're the same, practically the same. Okay, so later on we'll continue looking at the different elements of your LM model or mod 1. So let's now go here, class. So we have run this. And then summary of model 1. This is very important. Let's run this. Control Enter. Okay. And you have here, class, on this side. Let me use this one. Summary model 1 gives us what's really inside model 1. First is call, which means this is the formula that we use. LM formula is equal to hourly wage regression education. Data is equal to hourly wage. Then we have the descriptive statistics about your residuals. Okay, you have here a big residual 16.6. So which means that your actual value is way higher than your predicted value by 16.6 points. Okay, you have your first quartile median and your third quartile residual values. And then you have here the coefficients. The coefficients are the intercept and your education. Okay, and let me discuss what that means. Okay, remember, we were modeling hourly wage, which is your actual value here, regressed on education. This is your independent variable, where we were just using education. So this is a simple linear regression. So the regression model is actually y sub I is equal to a certain parameter intercept beta null plus beta 1 times education. Okay, plus a certain error term. Okay, if you're not going to put a hat here, class, then you have to put an epsilon here. However, if you're not going to put the hat here, which means it's the actual value, observed value, this is your this is your predicted value, okay, plus your residual. Okay, so what does this mean? Our intercept here is the value of your beta. So y sub I is equal to negative 0.90. Let me just truncate it to 5, okay? Round off ko na lang. Negative 0.905. And then here, education plus beta 1 here is 0.5454136 times education. Okay, plus a certain error term. So this is your model, class. This is your model. And so you have here the estimate 0.5. These are your parameters. You have their standard error. We'll discuss this in the future. Okay. Then you have your t value. And then you have the p value. What you learned in your earlier stat is that if the, say in this case, it's 3 stars. What does a 3-star mean here, class? 3 stars, 2-star, 1 star, and then just 1 dot here. Okay. So this means that this variable, education, is significant at the 0.001 level. So that's very good. Okay. If you see 2 stars, then it's significant at 1%. If 1 star, significant at 5%. If just a dot, then significant at 10%. In case your confidence in your level of significance is 10%. All right, so it's almost time. Now we have here some statistical information, residual standard error, degrees of freedom, multiple R squared, adjusted R squared, F stat, degree of freedom 1, degree of freedom 2, p-value. Okay, we'll discuss this next meeting. Okay, so we're going to continue just going through this, and our objective is for you to understand what all of these are, because you'll be exposed to many outputs like this. So it's important that we feel confident and know what these figures are telling us. All right. So are there any questions, class? Are there any questions?